Welcome to The Explainer. So today we're diving into a massive, and I mean massive, challenge in software development. How in the world do you test a complex product when there are basically infinite things that could go wrong? Well, we're going to use the ISTQB Advanced Level Syllabus as our map to figure out how to turn testing into this really powerful tool for mitigating risk. I mean, think about it. In software development, you're always in this tug of war, right? Over here, you've got this dream of a perfect, flawless product. But over here, you've got the cold, hard reality of deadlines, tight budgets, and just not enough people or time. It really does feel like you're being asked to do the impossible. Look, there is no way you can test every single line of code, every single path a user could take, or every weird thing they might type into a box. It's not going to happen. So the real skill, the secret sauce, is learning how to choose. How do you stop chasing this impossible goal of testing everything and instead get smart and test what actually matters? And yeah, that's where having a real strategy comes into play. All right, so here's our game plan. We're going to look at why testing feels so impossible, then dive into a strategy based on risk. We'll walk through the two main steps, analyzing and mitigating. Then we'll tackle some common problems you might run into and wrap up with how this whole approach turns testing into something way more valuable. Okay, so the solution to this whole impossible task thing, it's a really powerful concept from the ISTQB Advanced Level Syllabus. It's called risk-based testing, and it's all about systematically focusing your precious testing time and energy where it's going to make the biggest difference. This is such a perfect analogy. You know, a good home inspector doesn't waste time checking every single nail in the drywall. That would be crazy. Instead, they go straight for the big stuff, the foundation, the roof, the electrical panel. Why? Because those are the high-risk areas. If the foundation cracks, the whole house is in trouble. And that's exactly the mindset we're talking about here. Okay, so before we can start managing risks, we gotta know what we're actually looking for, right? The syllabus has a specific term for this: quality risks. Think of these as potential problems that are baked right into the product itself. You know, stuff that can make it crash, run super slow, have a security hole, or just not do what it's supposed to do. Now, this is a really, really important distinction. We have to separate quality risks from what we call project risks. A project risk is something like, uh-oh, our lead developer just quit, or our budget just got slashed. Those are huge problems for sure, but they're about managing the project. Risk-based testing is laser-focused on the quality risks, the things that could actually break the product for the user. All right, so how do we actually do this? Let's get practical. Step 1 is all about analyzing your risks. This means figuring out what could go wrong, and then figuring out just how bad it would be. So the ISTQB breaks this down into two really simple parts. First up is risk identification. This is where you get all the key people in a room, your devs, your business folks, product owners, everyone, and you just brainstorm. You make a big list of everything that could possibly go wrong. Then part 2 is risk assessment. You take that list, and for every single item, you ask two questions. How likely is this to happen? And if it does happen, how much will it hurt? And this is where a tool like a risk matrix comes in. You've probably seen one of these before, and they're a classic for a good reason. It makes you visualize the risk. See, you're plotting two things: how likely it is against how big the impact is. So a bug that happens all the time but is just a minor annoyance, that's maybe a medium risk. But a bug that's also super likely to happen and it could cause you to lose data or money, well, that's a critical risk. And bam, it shoots right to the top of your to-do list. Okay, so you've identified your risks, you've assessed them. Now what? Now we get to step 2, mitigation. This is where the fun starts. You get to design a test plan that's specifically built to attack your biggest, scariest threats. And here it is, the golden rule of risk-based testing. It's so simple, but so powerful. The amount of testing you do should be directly proportional to the level of risk. So those critical high-risk things in the top corner of your matrix, they get the white glove treatment. We're talking early testing, frequent testing, deep testing. On the flip side, those super low-risk items, maybe they just get a quick once-over. You're putting your effort where it counts. And the great thing is, you don't have to make this stuff up from scratch. The ISTQB syllabus points to several formal techniques you can use. Take FMEA, for example. That's failure mode and effect analysis. It's just a structured way to think through what could fail, why it might fail, and what would happen if it did. It's a perfect way to gather the data you need to fill out that risk matrix we just talked about. Okay, but let's be real. Theory is great, but applying this stuff in the real world with all its chaos, well, that can be tricky. So let's talk about some of the common traps people fall into and how you can avoid them. And hey, don't just take my word for it. This Reddit user studying for the exam absolutely nails it. They say there's a reason why it's advanced level. And they're so right. There's a massive jump between the basics and this kind of strategic thinking. Being able to apply these concepts when things get crazy, that's what makes someone a true test lead or manager. Okay, here's a big one. What happens when you're staring at your list of risks and you just have no idea how to score them? This is probably the #1 problem teams have. How do you really know the likelihood or the impact? It can feel like you're just pulling numbers out of thin air. Well, the syllabus has a really practical 2-part solution for this. First, don't guess. Use data. Look back at your old projects. Have features like this failed before? What happened? Use that history. And second, and this is crucial, don't do it alone. Get other people involved. A developer sees risk differently than a customer support person, who sees it differently than a business analyst. You need all those perspectives. Here's another classic trap. The syllabus calls it déjà vu, which is perfect. It's when your risk meeting becomes this boring routine. You just pull up the list from the last project, kind of copy-paste it, and nobody really thinks about it. The whole thing just becomes a box-ticking exercise. So the fix is pretty simple. You have to keep it fresh. Make sure you have the right people in the room for this project, not the last one. And even if a risk looks familiar, challenge it. Ask, is this really the same risk in this new context? By forcing yourself to tailor the analysis every single time, you make sure the process actually stays meaningful. So, when you put all these pieces together, something really cool happens. This is the ultimate payoff. Your testing work stops being just about finding bugs and starts becoming a kind of business intelligence. You're giving the entire company critical information to help them make smarter decisions. And look, this isn't just some fuzzy, feel-good idea. We're talking about a massive, real-world financial impact. Check this out. A cost of quality example from the syllabus calculates an average savings of $3,300. That's for every single defect you find before it gets out the door. That's real money, and that's a language the business definitely understands. And this, right here, is why all of this matters so much. When you adopt a risk-based approach, you fundamentally change the conversation. People stop asking you, how many tests did you run? Instead, they start asking, how much risk did we get rid of? You're not just a bug hunter anymore. You're a strategic partner who's actively protecting the business. So, I want to leave you with one final question to take back to your team. What is the one risk? You know the one I'm talking about, the one everyone kind of knows is there, but nobody's talking about it, the one that could actually sink the entire project? Find that risk, because that's your starting point.